Go ahead.
All right, my group for next year. I'm Zach, I'm one of the mechanical engineers on this project. This is our final design for the drying chamber. You probably already know this, but its function is to hold the processed mangoes, the mango paste to be dried. So this is made out of 24 gauge galvanized steel sheet metal, which we bent to shape. The main chamber is one big piece, and we just bent the walls up at 90 degrees. And we have a separate piece for the lid, which we attach via hinges on the end. We have everything put together with bolts right now, nuts and bolts, but it's recommended that this would be assembled with rivets because they're a little more permanent. The bolts like to unscrew themselves all the time, so if you can get your hands on rivets, that would be great. Anyway, as you can see, this is the front end, I guess you could call it. This is the side that will attach to the collector itself. We've put gasket tape to try and get a good seal between the interface of the drying chamber and the collector. There are 4 holes in this end cap, I guess you could call it, and then there are four holes in the flange on the collector. And they attach by putting the bolt through both holes and then screwing them down tight so it pulls both pieces together and up against this gasket tape to get a nice seal. Then we have this fan array in here, and the reason that it's not attached to these holes as well with the same bolt is because you wouldn't be able to reach in to the collector to actually tighten these bolts on. So currently, in order to install it, you have to have the fan array out and then attach the drying chamber to the collector, and then you have to install the fan array, which is a bit of a pain in the butt, so that's an improvement that can be made somehow. And the fan array is attached, again, with the sheet metal that we just bent into 90-degree corners here and bolted into the side of the wall. As you can see, we have 2 pieces of sheet metal. We have this flange and then another L bracket that we made. You could definitely make that out of one piece. We just hadn't thought of doing this design initially, so it ended up being 2 pieces. Then we have all this room for the trays, which is where you put the mangoes, obviously. And then at the end, we have another end cap. You can see that the ends are very similar, except for this side having a very long top. That's, again, to help get a good seal so that air doesn't leak in, except from the collector. So both ends have these end caps, which help add a lot of rigidity to the box. Without these end caps that wrap around the ends here, the walls were kind of free to move at the ends, and the box is very flimsy and unstable. So we've added these for sealing air and for adding stability. As you can see, we have more gasket tape along the top here and along the top of the lid, so that when it closes, it helps seal it off from any of the outside air. Keeps the hot air in, keeps the cooler air out. You can also see we have this netting attached to the end cap. That's another function of these end caps, is it makes it easy to attach things to the drying chamber. We also installed handles on the side for easier carrying. This thing was a bit of a pain in the butt to carry, to have to wrap yourself around it, or have 2 people on the ends, but now it's a lot easier to just lift it on out. It's not that heavy. Yeah, there's a handle on each side. These bolts are super long. We didn't trim any of the bolts we used. Yeah. Finally, we have the legs. This is one of the more challenging things. Let's turn it over. Oh, flip it over. Yeah, that's probably good. The legs were a bit of a challenge because, again, stability was a big problem. It's fairly thin sheet metal, so it doesn't like to stand up on its own. It liked to wobble and fall over. So we wanted legs that were, the whole thing's supposed to be somewhat lightweight, not super heavy, because you got to carry it around in the mountains sometimes. But it's also got to be fairly durable. It's got to stand up to some abuse. So we ended up using conduit piping on each end here. You can see that it's just bent at 90 degrees. And this stuff is actually way easier to bend than you might think. We just clamped it to the end of the table, used our body weight, and bent it over the edge. So then we attached the conduit piping legs to the box with some of our sheet metal. We were able to cut out strips of sheet metal, hold this conduit piping to the table, and then hammer the sheet metal to conform to this shape. And you're probably wondering why there's tape on each end. That's because this would like to slide back and forth, which I guess with the side supports, you don't need the tape anymore to constrain it from sliding, because these fulfill that purpose anyway. So that's the main part of the legs. Then we have the supports on each side. So we have cross members at an angle here, and we also just have horizontal. So these horizontal supports prohibit the legs from bending in or bending out any further, because like I said, these are pretty easy to bend. So that makes the legs hold their shape. And these keep the legs at 90 degrees so that the box is standing upright instead of leaning over to one side or the other. Yeah, in order to bolt these in, we had to make a little bit of a flat spot, the angle grinder. But all in all, it wasn't too difficult to manufacture. And as you can see, it's not very heavy, and it's very stable. One of the concerns that Professor Stevens had was people just accidentally bumping into it, breaking things. So, yeah, stands up to the test. Anything else we want?
I don't think so.
Yeah, I think that's about it.
All right.